Hello, welcome back. So this is part two of the video. In the last part, we ended up with the step of achieving the IP address. This is one of the most important things within the attack of Hydra, and I'll explain why very shortly. If we head back over to the virtual machine, this is where we were up to. So we have our attack passwords list within a documents folder. We've got Hydra installed and we've tested that. Now we're ready to launch the attack. Just copying the attack from here, command I prepared earlier. So I'll just paste this in, but I won't run it just yet. I'll give you an understanding as to how we got there. So what this attack means is we've got Hydra, we've got the IP address, which we just found out using CMD on the client machine. We've got -S, which stands for port number. We've got -V, which is a debugging tool, which allows us to see every different option that Hydra uses. We've got a HTTPS form, as we know that the project is HTTPS. Other documents that we need in order to get another piece of information or to get this attack working is we need to know the string where this post attack is going to process. We also need to know the username and the passwords and the impact of a negative response. So we need to teach Hydra essentially what a bad response looks like, so it knows what a good response is, and then once it has that good response, it will cease the attack. So if we go back over to Google Chrome, if we use the developer tools inspect, we can see here that we've got immediately action gp/login, so we know, and it's a method /post. So within a second, we know that we've got HTTPS from up there. It's a post, so a HTTPS post form, and it's acting on /gp/login. If we look into that a little bit more detail, we can see immediately the name that's used in this file, this input here, is GP username, and the name which is used within the password is referred to as the password is GP password. Bingo, we know exactly how to tell Hydra how to look for it. However, we just need one more piece of information. So we know, as an attacker, we know that it's steve@gp.net, which is the information of the username. However, what happens if the password is incorrect? So instead of typing in Ronaldo, say we type in Messi. We receive an error from the server. It says bad login. That's it. We've got every single piece of information we need. So we'll head back over to the VM. So just to run through this one more time. So this means Hydra, we're telling it to launch the application Hydra. We're feeding it these pieces of information: IP address of the client server, the port number, the type of attack, HTTPS form post, GP login, what represents the username, what represents the password, and here we've got what represents an incorrect login. So that's what we're testing against. Next, we've got -L, which tells it that we know this is a definite username, steve@gp.net, and uppercase P tells us to iterate through these passwords, top passwords.txt, and .f tells Hydra to stop running once it's found a successful combination. So we'll send this to go. Oh, sorry, and just get rid of that .f for the moment. It can sometimes throw it off. So here we are. We've got Hydra running. We can see it's got running steve@gp.net, all these passwords going through it, just to prove that it is actually affecting the clients. If we look at the console for the project server in IntelliJ, we can see immediately we've got all these requests going through. Just to pull it back to an earlier one, we can see login, failed login attempt, steve@gp.net, password baseball, has tried Andrew, and it's going to keep going until it finds a valid information, because we've not got any restrictions on number of attempts. So we'll head back over to the VM and we'll see what it's doing. Okay, it's fantastic. So just to make this a little bit bigger so we can see exactly all the information the VM is producing for us. So in that list of top passwords, we've got 10,000 listed in there. So here we are. We've got Hydra going through a dictionary attack. We've got 10,000 potential passwords. We're now almost coming up to 900 through them. So for all the passwords, because we've told it steve@gp.net is definitely a password, and it's going to pass through all these passwords until it finds a successful one. And here we are, no less than about a minute in, success. We've got HTTP form, post, this is the host address, this is the login, this is the password. Shall we try it? steve@gp.net, type in the password Ronaldo. Boom, we're in. Hydra has officially shown the vulnerability within the application. Come back for the next part where we'll be addressing how to fix this vulnerability.